Hello, today we're going to be talking about propagation delays, all right? And what that is, to simply put it, is the time that it takes for a signal to enter into some gate and then be outputted, all right? So to show you how the propagation delay, how it works and how it happens, we have this little setup here. We have an input going into one part of an AND gate, and then we have the complement of that going into the other AND gate. So if you look at this, you should think that this will always output 0. And that's because, of course, we have 1 being always inserted, and we'll always have the complement of that being inserted into the other input there. All right. But if we actually step by step go through what's really happening, we can see the effect of propagation delay. So I'll go ahead and change this to a 1 here. And if we take our first step through, we could see the 1 being inserted into the other end of the AND gate here. And then there's going to be about a 10 nanosecond delay before this output here changes from the complement of 0 to the complement of 1. Or in other words, from a 1 to a 0. So if we hit it one more time, you can see, boom, we have an output of 1, which should never, ever be the case. But because of that 10 nanosecond delay here, as well as a 10 nanosecond delay here at the end of this AND gate, but that's not important for our output really. Really what's important is here, this 10 nanosecond delay at this NOT gate. That gives us an output of 1, and that should not be happening. And if we hit this one more time, we should see it reset back to 0 as that 10 nanosecond time is up, and it changes this 1 to its complement back to a 0, in other words, and then we get the output of false through the AND gate, because a 1 and a 1 is the only case where an AND gate will output 1. So, and then you could see that finish through. So let's go ahead and move on to a larger circuit where this effect can be analyzed. All right. So here we have a 4-bit adder, and I'm going to insert in a specific value, specific set of values. I believe it was something like that. All right. And if we go ahead and step through this circuit, you're going to see a lot of these the propagation delay effect come to life. So let's go ahead and start going through. We have our inputs going into our full adders. And if we step through a few more times, you'll see that nothing's happened. I've clicked twice and nothing has happened. And that's because these full adders consist of 5 gates in them. In each and every full adder, there's 5 gates. All right. So we'll step through a 3rd time, and then a 4th time, and then a 5th time, a 6th time, and we get an output here out of the C out of this first gate. So that took a few steps, but that's just the signals going through each and every gate one at a time. So we get our first output going into the second full adder here. And then it looks like we have 2 more steps later, we get our first sum out for S1 with a 1. And then for the 3rd full adder, we have a sum out of 1 as well. But watch. As we cycle through, S1 switched from a 1 to a 0, excuse me. And that's because our inputs out of C out here came in at a later time, and that altered what was going on after the fact of what A and B were doing firsthand. So that's what happened there. And then you could see the same effect happen for this output here in S2, where this C out came out at a later time, nanoseconds later, before A and B originally had their first inputs there first. So they calculated whatever the sum needed to be first before C out of the second full adder came into this full adder here, where then the effects happened, of course, nanoseconds later once again. So, and I believe, oh, and then we get a 1 there. So yeah, we are basically adding a binary 5 in the B's inputs, and then a binary 3 in the A's inputs. And of course we get an output of 8, But as we were stepping through that whole process, we were getting a bunch of ones in places where they should not have been. So there are some limitations to Logisim's propagation delay. So I'll go ahead and bring up this little user's manual that is in Logisim. And you can see here that they quote that the algorithm is not sophisticated enough to account for gate delays, but not realistic enough to account for more difficult phenomena like varying voltages or race conditions. So that is important to keep in mind. All right, well, anyways, that's enough for me. Thank you for watching.